Now you may have noticed that as we were studying polynomials and the operations between them, we kind of glazed over one operation. We can do polynomial addition, no problem, that's combine like terms. We can do polynomial subtraction, same deal. We can do polynomial multiplication, that's just a variation of FOIL and the distributive property. And we can factor polynomials, which is undoing the multiplication without actually doing polynomial division. And so what we're going to talk about today is polynomial division. And I'm going to say this, and this is all you really need to know about polynomial division. Polynomial division equals long division. So if you never learned the long division algorithm when you were in elementary school, you're in for a world of hurt because it is literally just the long division algorithm. So for example, if I see x cubed minus 5x squared plus 4x minus 2 over x minus 2, I can do the division for this polynomial by just using the long division algorithm. So remember what these are called. The number on top is called the dividend. The number on the bottom is called the divisor. And so what I do is I take the divisor, x minus 2, and draw my long division bar, and I write my polynomial in there. So my dividend gets written underneath the division symbol, and then I just have to divide. Looking at this polynomial, I think, well, what do I have to multiply x by to get an x cubed? And well, I have to multiply it by x squared. And so then I take x squared and I multiply it by x minus 2 to get x cubed minus 2x squared, right? And so then I have to subtract that off to get a 0 there. And then negative 5x squared minus negative 2 is negative 3x squared. And then I have to think, well, I have to bring down the 4x, just like long division, and then figure out what I have to multiply x by to get negative 3x squared, which is minus 3x. So then I get negative 3x squared plus 6x. Then I have to subtract this off, and I get this to be a 0. And 4x minus 6x is negative 2x. Bring down that minus 2, and then I have to think, well, what do I have to multiply x by to get negative 2x, which is minus 2. So I get negative 2x plus 2. And, oh, sorry, plus 4. 2 times 2, right? And then I do my subtraction, and I get negative 6 as my remainder. And so I don't write it as remainder 6. I have to write it like this, negative 6 over x minus 2. So my quotient is x squared minus 3x minus 2. My remainder is negative 6. And this polynomial here is equivalent or the same thing as x squared minus 3x minus 2 minus 6 over x minus 2. So when performing polynomial division or long division with polynomials, I have a few things you need to remember. First, make sure that you arrange the terms in order of decreasing degree. That's both for the dividend and the divisor. And you have to add missing terms as placeholders. So if you're missing a squared term in a cubic, you have to add it as a placeholder when you do the division. So let me show you an example of that. So let's say I have x cubed minus 1, and I'm going to divide it by x minus 1. Now I can factor x cubed minus 1, and I know one of my factors is x minus 1 because that's the difference of cubes, but I just want to demonstrate this long division. So my divisor is x minus 1, goes on the outside. Inside, I have to have x cubed minus 1, but I'm missing the squared and linear term, so I have to add them in as placeholders when I do my division. And so then I just do my regular long division algorithm. I figure out x times what number gives me x cubed, which is x squared. Then I multiply x squared times x minus 1 to get x cubed minus x squared. And then I have to subtract off that binomial to get x squared, right? And so then from there, I think, well, carry down the 0x, which, you know, isn't really that helpful, but it's good for a placeholder, and that's about it. So x squared times what, or what times x gives me x squared? That has to be a plus x, and so then I get x squared minus x, subtract off that binomial, and I get x minus 1, and then, well, x minus 1 is just plus 1, which gives me my quotient of x squared plus x plus 1. And there's no remainder, as I anticipated, because I already knew that I could just factor this and divide that x minus 1 out cleanly. Now let's have you try a couple. So why don't you take x squared plus 3x plus 5 and divide it by x plus 1 and see what you get. And then take 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2 and divide that by x squared plus 2x minus 3. So let's see if you got those answers right. So for the first one, I got x plus 2 plus 3 over x plus 1. And for the second one, I got 2x squared plus 1 plus x plus 1 over x squared plus 2x minus 3. Now, it is really easy to make a mistake in the long division algorithm because you have to keep track of a lot of terms and a lot of signs. So I'm going to show you a quick way to check your answer given that I've only given you one variable. Now, I can totally mess with you and give you two variables, and this way to check doesn't work anymore. But here's what you can do. So what I did was I typed in the original expression, this as y1, and then my answer as y2. And if I did everything right, that means this answer and that are equivalent, and I'd get the same table. And if I look at my table, my tables are identical, so I did the division correctly. And once again, this is a good way to check as long as I don't mess with you and give you two variables.